All right, so we start a new section 6.1 today. We're going to add, subtract polynomials. And we're going to do a little bit with a graph. So adding, subtracting is going to be part of our main stuff today. Okay, we're going to be evaluating them and identifying what they are a little bit. We're going to subtract them. So what does a polynomial look like? Well, how about 5x to the fourth minus 3x cubed plus 16x squared minus 2x plus 10. Poly meaning many. Poly is many. So each of these are monomials, okay? So that's a monomial, monomial, single term. We put them together with plus and minus signs. Becomes poly. Poly meaning many, okay? We have a binomial. Binomial is 2 terms. Trinomial would be 3 terms. Monomial is 1. So poly, we're going to stop at 3. We're not going to go past that. We're just going to call them all what? Polynomials. So you won't have to name them. So in the homework, if there's a saying that says name them, like quintuplets, you know how they have that many babies or something? We're not going to be naming them in that. Just say polynomial past 3s. Everybody got that part? Because the book will ask you to name them and it'll come up here in a second. But monomial, binomial, tri, we're going to call everything else after that poly. First day? All right. So that's kind of what they look like. We're going to not do the warm-up today. Is that all right? I very rarely do. So we just talked about that. A monomial, a polynomial, the degree of a monomial. And the degree of a polynomial, we're going to figure out. The degree is the highest power. So a monomial might look like this, of course. 2x to the third. So what is the degree there? The degree is 3 because that is the highest power. So that degree is 3. Now, we could have something like 2x to the fourth, y to the second. Still a monomial. In this case, the degree would be 6 because we need to add 4 and 2 together. So the degree is the highest power of a single monomial. If there's more than one exponent in there, or a variable x and y, you got to add those together, okay? Degree of a polynomial will be the highest monomial degree. Lead coefficients, pretty explanatory, be the lead, whatever number's in the very first, if we put it in standard form. Y is 2, tri, of course, is 3. So there's a little explanation of our terms and what we're going to be talking about. So let's take a look. These are very simple. We have z to the 6th. What would be the power? What is the degree of z to the 6th? Well, it's a monomial, and it is a degree of 6. Be careful with 5.1. It's a constant term. Constant term has a degree of 0. Degree of 0. Mike, will you shut your computer, please? Thank you. Degree of 0 there. So that one can be a little tricky. Roll down, there's 6. Let's try this guy right here. Now remember, we're stepping it up a little bit. It's still a monomial, still a single term, but we have 2 variables, x and y. Y's cubed, x is the first, so the degree of this is 4. Here we have a squared b to the first c to the third, so the degree here would be 6. How are we doing with degree of a monomial? You okay there? That's pretty easy stuff, and I'm going to ask one of those on the exam then. That's an easy point, isn't it? I think it should be. Let's try another set. Don't even write them down. Just look up here and say, what do you think? Uh-huh. What do you think? Okay. Letter C, what do you think? 5. Letter D? 9. Okay. Everybody feel okay? Now remember, that's within the monomial add then. If it's a polynomial, don't go adding all of them up. Okay? You'll see that when we do a poly here in a second. All right, degree of polynomials given by the term with the greatest degree. Okay, also lead coefficient. So this is basically a polynomial. How many terms? There are 4 terms here. So the degree is 3 because that is our highest power within each mono. So we have a monomial plus a monomial plus a minus a monomial. Okay? That is called standard form. Standard form is when we put the powers in order, isn't it? You remember that from Algebra 1, I'm sure. That would be standard form. Lead coefficient, we have the highest power out front. The lead coefficient is whatever would be there. In that case, this is 5. This has a degree of 3. And there are terms, 4 terms, each of degree 3, degree 2, degree 1. Now, here's what I was talking about. The degree of this polynomial is 3. Everybody see that? You don't be adding these up. Okay? So that degree is 3. Let's practice a couple of these. Here's what I'm sorry, before I practice, I'm going to talk about this. I'm not going to make you name these things right here. Okay? So if it comes up in the book, name them, you don't need to worry about that. Just say polynomial. You don't have to say it. We should know what a constant is, okay? Binomial or linear, quadratic, we've hit those pretty hard. Past that, we're gonna go with just polynomial. Okay, hopefully that's pretty clear. All right, here we go. Rewrite the polynomial in standard form. Let's do the first one together, letter A, and then I'll let you try B. So standard form would be to the highest degree first. So that's gonna be minus 5x squared plus 4x plus 3. There we are, standard form. Standard form. Okay, so that takes care of standard form. Then identify the lead coefficient. What is the lead coefficient in letter A? Polynomial. It is -5, isn't it? What is the degree of this polynomial? Well, look at the highest monomial. It would be a degree of 2, isn't it? And if you missed the number of terms, shame on you. There are 3 of them in there. Try that next one. Put it in standard form. Those of you engaging, you can do it mentally if you want, or write it down. There is at least one person in here that's more mental than others, and that's me. I am becoming mental. The older I get, the less I remember. Why does it work that way? The less I can do, too. I hardly lift my hand sometimes. You know what I mean? Rotate. I used to get up, Mrs. Drummond and I used to get up and just say, let's go get him. And now, this morning, I get up and say, how do you feel? Well, I feel okay. How do you feel? Well, I got this is, all right, well, can we make it today? Yeah, I think we can probably make it. That's there. All right, I'm gonna put this 8x to the 4th first, plus 3x squared minus 4. That's standard form. What's the lead coefficient? Of course it is 8. Degree is 4. Okay. Let's just do B. We're not going to do A. Same thing. See if you can get B in standard form. Put B in standard form for me. Woohoo! Basketball game last night. Hung in there pretty good. 4th quarter, we couldn't score, could we, Luke? 1 point in the 4th quarter. I don't think the cheerleaders cheered hard enough.
Oh.
Just yeah, we bricked a few foul shots too, they didn't. Did you read it? Oh.
That's all.
1 point?
Huh?
1 point?
Yeah, in the whole quarter.
Yeah, that's all we scored. What did you say it was? didn't hear what you said. You said that was
all.
Huh?
I mean, I'm 100% from the Falcons on this.
What sport did you play this year?
You got me right.
You're 100% with your video games from the foul line, right?
What do you mean? I was the best foul shot shooter in Yoder's team.
X to the third will be first. Minus 18x squared. Plus 2x minus 5. Lead coefficient, be careful what your lead coefficient is. 1, isn't it? Okay? What's the degree of this polynomial? 3. Degree of 3. And of course, there are 4 terms. All right, we're gonna head on down the road here. Let's go add and subtract polynomials. You can make sure they have to add like things. So that would be 2x squared plus 3x squared would give me 5x squared. They need to be like exponents and like variable. And you can add those together. See what you can do there? Add stuff together, put it in standard form. So what do we want to add first is the highest degree monomials. And it looks like those are going to be what? X to the third. We got a couple x to the thirds up there. All right, we got 2x to the third and 1x to the third. That's going to give me what? 3x to the third. Now, personally, when I have them all written out, I'm going to go ahead, and I know I've done those already. So I have x to the third. Now I'm going to look for the next power would be x squared. Oh, I got one of them and only one of them. So it's going to be plus. Now I'm looking for my single x's or my degree of 1. I have a negative 1 and a positive 7, so that's going to give me positive 6 of those. And now I'm down to 9 and 4, which gives me positive 13. All right, there's my polynomial. After I add all those polynomials up, I add like things. I have a lead coefficient of 3. A degree of 3, and I have a 4-term polynomial here. How we doing, my friends? Everybody okay there? I don't want to belittle that, but I think that's pretty easy, isn't it? Does everybody feel okay about that? I do have another plus. Oh, this one's minus. So let's go ahead and do the minus now. So that would be 3 minus 2x squared. We need to distribute minus x squared minus 6 plus x. So we'll do one subtraction, and then we're going to move forward, I think. So we got to distribute that negative, or that subtraction. That's the only way you can, only problem there, you can mess that up. Make sure you distribute there. Degree of 2 is my highest. I got neggy, so it looks like that's going to be negative 3x squared. I'm going to end up with plus x, and I'm going to end up with minus 3. So lead coefficient here is negative 3, and my degree is 2. Woohoo! How we doing, everybody? Not bad for Wednesday, so it doesn't get that hard, is it? Seems like I'm putting a few of you to sleep at least. That's good. That's bad. Do we need to do another one? We feeling okay? Is everybody okay? I think you probably are. This is a plus. Let's see our like. We'd start with 16 x cubed. We'd get the minus 30x squared. We're going to have plus 6x. and we're gonna end up with minus 16. Lead coefficient 16, degree is 3. Everybody okay? I'm ready to move on if you are. Got it, Trent?
Just 1 second.
Yep. All right, make sure you distribute, okay? And do the same thing here. All right, last thing, we're gonna be analyzing some of these polynomials. And our graphing calculator is going to be a very useful tool. So if you have that available, you can sneak that out right now. Basically, we are going to use our graphing calculator to determine how many real roots there are. How many real roots there are, okay? So, we have 2x cubed minus 3x. Now the degree of this is what, folks? 3. So this could cross the x-axis 3 times. The degree of the polynomial determines the possible real roots. There'll be no more than 3 crossings. It can never cross more than the degree. It might not cross all 3. There could be some imaginary roots, okay? There could be some imaginary roots. What is the square root of a negative number, which we've been working with, right? I. So basically, you're going to grab your graphing calculator, go to y equals and put this in, and look and see how many times it crosses the x-axis. So practice that. 2x to the third minus 3x. You should get a graph looking like that. 1, 2, and you would say it has 3 real roots. Why? Because it crosses 3 times. Now, if it would only cross once, you would say 1 real root, then you would know the other 2 are going to be what? Imaginary roots, okay? They would be imaginary roots. So watch your cross methods.
First of all, thank you.
Now, what's the degree of this b? It is degree of 4. So we're either going to have 4 real roots or some number under that, okay?
Sorry.
So how are we going to determine it? You're just going to throw in your calculator again, okay? If you want to take a quick look at that and see what you can get, see if you can get this same. It's good to practice once and make sure you can get what I getting. 1, 2, 3. Okay, so this has 4 reals again. Remember, it might not have any reals. The real solutions are where it crosses that x-axis. Those are the real solutions. So you might graph one of these and it doesn't cross at all, then you say there's no real. Is that clear, everybody? How's it going with the calculator? Getting them in? Just a heads up, from now on, no phone calculators will be allowed on assessments. So I know that's going to be a pain for some of us. I have 2 of them. I'll loan those around if we can need them. But phone calculators you can use, for your homework and everything, but you will not be able to use those for assessing. If you need to, get the calculator put on your computer, put on a Gen Yes and ask Mr. Pallotta. He can load that calculator up for you. How are we feeling about this idea right here? Graphing them, okay? I'm going to show you another set just because how many possibles would there be for this guy right here? Well, it's a degree of what, folks? Degree of 3. So how many times it might cross 3 times? It might not. How about this one? How many times might it cross? Might cross twice. Let's see. Okay. This one had 3 real roots. How about this guy right here? None. Okay, no real roots. And that's how you determine that. Does that make sense to everybody? So the degree tells you the possible roots. You need to graph it. How many times it crosses the x-axis? Those are real roots. So letter B has 2 roots still, but they are imaginary roots. When we would put that in a quadratic, we would get a negative square root, and we have I involved. We've been solving those. You did it in chapter 5, didn't you? Couple of odd problems. You can knock those out. I'd appreciate it. You can submit on Canvas, of course, as usual. And if you need to take chapter 5 assessment yet, find some time, or if you're interested in doing it again, find some time.